The diagram shows a block of mass 12 kilograms. So there's a block here weighing has a mass of 12 kilograms, so its weight is 12 g newtons. Inclined on a smooth plane at 30 degrees. So it's smooth, so there's no friction involved, and this angle here is 30 degrees to the horizontal. To keep the block in place, i.e. it's in equilibrium, it is attached to a light rope inclined at 10 degrees to the plane. Find the tension P in the rope and the normal reaction R of the plane on the block. Right, there are several different ways of doing this problem. First we're just going to do by resolving forces. So if we have the I going this way in line with the slope of the plane, and then J will be perpendicular to it. So resolving in the I direction, we're going to have this one here, so it's going to be P cos 10 minus 12g sine 30, which is going to be this one here, and that's going to be equation 1. And in the j direction, we're going to have several things here. We're going to have r, and we're going to have P sine 10 plus r, and then we're going to have to take away minus 12g cos 30, so it's going to be this one here. Right, from 1, we're going to have that P is 12g sine 30 over cos 10, and taking g to be 9.8 meters per second squared, that gives me 59.707. Which is 59.7 newtons to 3 significant figures. If we now substitute that into equation 2, so instead of P we now put 59.707, don't put the rounded off value in, 59.707 times sine 10 plus r minus 12g cos 30 is equal to 0, just writing that out again. Then r will be 12g cos 30 minus 59.707 sine 10, which gives 91.476, which is 91.5 newtons. That's one way of doing that problem. Another way is to use a triangle of forces. So just look at the diagram again. So we have to draw a triangle of forces using this force, and this force. So starting with this one which goes directly downwards, then P will be 50. Now it's 50 because if you were to move that line down here, this will make this triangle right angled, so this angle at the corner here would be 60, but it's all inclined at 10, and therefore it's 50. The hardest thing to do with this type of method is to work out the angles. This angle here would be 30, which is the same as this one here, and therefore we can find this one by using the sum of a triangle, therefore it's 100. Then using the sine rule, we get P over sine 30 is equal to R over sine 50 is equal to 12g over sine 100. Rearrange it, you're going to get P is 12g sine 30 over sine 100, which is 59.7 newtons, and therefore R will be 12g sine 50, taking the 50 up here, dividing by sine 100, which gives 91.5 newtons, the same as what we got the first time around we did this problem. And the final method is to use Lemmy's theorem. So this time we take a point, and let's take this point here. So this goes directly downwards. Here goes R. So R is going to be, and there goes P. This angle here is going to be 80. Why? Because this here are 90, and therefore this is already inclined at 10, therefore the remaining angle must be 80. This angle must be 130, which you get by doing 10 plus the 90 plus the 30, and then the other one you can get by adding up to 360. These add up to 360. Or you could have said this here is a straight line, therefore this is 30, this must be 150. And then P over sine 150 is equal to R over sine 130 is equal to 12g over sine 80. So we always do this over the opposite one. This is Lemmy's theorem. And therefore P will be 12g times sine 150 over sine 80, which gives 59.7 newtons again, and R will be 12G sine 130 over sine 80, which gives 91.5 newtons again. So there's three different methods of doing the same problem. You can only really use the second two methods, if there are three forces acting on the situation. If there's more than, you have to use the first method.